Hello guys, welcome back to the CCNA video series brought to you by ABY Design and Tech. In this video, we're going to dive deep into Power over Ethernet, understand what it is and why we need it. So to begin, what's Power over Ethernet? And simply put, it's just using an Ethernet cable to provide a device with both network access and with power. And that's all. And literally, that's all there is to it. Now, I know what you're thinking. Abdul, does that mean I can supply any device with power? And unfortunately, the answer is no. So the Power over Ethernet standard was created by the IEEE. It's more specifically is 802.3. And that standard essentially defines limitations on how much power we can supply out each port. So obviously, depending on what IEEE standard your switch supports, will obviously dictate the max amount of power it can supply out each port in watts. Now, what was Power over Ethernet created for? So if I can't power every device, if I can't power my switch, my laptop, my computer, what can I power? Well, let's think about devices where it may be difficult to install a power supply or a power socket for those devices. Prime examples, IP cameras and APs. So those two types of devices, they may be located in certain areas where it's difficult to get power installed, and it may be costly to get power installed. However, there's a data point near there, and it's easy to run an Ethernet cable from the data point into the camera. That's how Power over Ethernet was born, is to allow us to provide power to devices which A, don't need a lot of power to power up, and B, where maybe an inconvenience to install a power supply there. Allows us to use a single Ethernet cable to give the device network access and to supply that device with power. The most important factor to consider is the device that we want to supply a Power over Ethernet to has to actually support Power over Ethernet. And so the three most common devices that we will see use Power over Ethernet are going to be access points, IP phones and IP cameras, and that's in every organization. So as you can see, access points and IP phones, they will be the most common type of devices which will use Power over Ethernet. So how does Power over Ethernet work? Well, simply put, we just send power down the twisted wire pairs inside of an Ethernet cable. Now I know what you're thinking. Okay, Abda, could that interfere with the data signals that we're sending or the traffic that we're sending? And the answer is no. The reason being because power and data, they both transmit their signals at different frequencies. Power is transmitted at a lower frequency than data, so that means that there can be no clash, no interference, which means we can support power and data over an Ethernet cable. And so let's get technical now. So the technical term for a switch is known as a PSE. So a PSE, or power sourcing equipment, simply put, is just a device which provides power to a device which needs power over Ethernet. A PED, or a power device, is a device which needs its power over Ethernet. Now I know what you're thinking. If power over Ethernet can't be used for every device, and it's only used for a certain type of device, how does the switch detect which devices need Power over Ethernet and which devices don't? Because this is the truth. If we supply a device with power and that device doesn't need Power over Ethernet, that can cause an issue because that device can actually break. And I've actually seen this in real life where, unfortunately, I made this mistake. I configured Power over Ethernet on a port, and I didn't realize that the device on the other end already was getting its power supplied by its own power supply, and that actually broke that device because it was supplying it with too much power. So obviously the switch has to be clever enough to pick up and understand which devices need Power over Ethernet and which devices don't. And so there are two methods. The first method is defined by the IEEE, and this method you will see used on HP switches, Cisco switches, Juniper switches, so all vendors. And then there's a method defined by Cisco. So it can only be, you'll only see this method between Cisco devices on Cisco switches. So the first method, which is the IEEE standard, the 802.3 standard. The way that it works, or the play-by-play, we send a small voltage across the Ethernet cable. Then we measure the resistance. If the resistance on that cable is 25,000 ohms, that means a power device exists on the other end. And simply put, the power device and the switch will exchange messages, and the power device will tell the switch, this is how much power I need. Now obviously, that's all well and good, but obviously the switch has to be able to support the device request. If a device is requesting, let's say, 30 watts of power, and the Cisco switch can only provide a max amount of power of 15.4 watts of power at each port. Unfortunately, buddy, I can't provide you with enough power to power you up. So unfortunately, you will need to have your own power supply. And so these are the different classes. So class 0 is the default. If, for whatever reason, a endpoint device or a power device doesn't support power class message exchange, then by default, if a switch detects a PD, but it doesn't receive any power class message, it will just provide 15.4 watts of power out of that interface. Class 1 is going to be 4 watts, class 2 7 watts, class 3 15.4 watts, and obviously class 4 51 watts. And there are other classes as well. So let's see 802.3 in action. So simply put, a voltage sent across the link, I measure resistance at 25,000 ohms, that means as a power device. AP1 tells switch 1, I need class 3. So I need power class 3. Switch 1 supplies him with 15.4 watts of power. It's as simple as that. So now if we go over here, IEEE standards. So obviously, the amount of power a switch can provide at each port depends on the IEEE standard that switch supports. So we've got PoE and PoE+, which are the two most common types of power over Ethernet implemented on Cisco switches. So power over Ethernet, we can support a max of 15.4 watts of power per port. PoE+, we can support a max power of 30 watts per port. Now PoE+, we can either support 60 watts or 100 watts. And as you can see, the newer power over Ethernet implementations or standards support more power per port. The idea is to essentially have all end devices in the end being powered by Ethernet, because it eliminates the need to have physical power supplied there, and also it makes it easier as well, because if we ever need to restart or power cycle something, we can literally just shut down that Ethernet port and then re-enable that port. And you will see that a lot when we have issues with cameras or IP phones or APs. You can literally just shut down that port, that will power cycle it, and we re-enable that port, and then we've just restarted that device. As you can see, PoE and PoE+, we use 2 twisted wire pairs to send the power, and with PoE+, we use 4 twisted wire pairs to send the power to the power device. Inline power, this is a method used only by Cisco switches to detect whether a power device exists on the other end. And all that happens, the switch will send out a 340 kilohertz test tone, which is sent on the transmit pair for that link. If the switch receives that 340 kilohertz test tone on its receive pairs, it knows, wait a minute buddy, a power device exists on the other end of this link. So guess what? We're going to exchange CDP messages. He will tell me how much power he needs, and I will supply him with that much power. And again, I think in the CDP message, there's like a field called like the power class or something, and it'll essentially tell the Cisco switch, this is how much power I need based on the power class default values. Now, diseases in action, simple as that. 340 kilohertz test tone is sent over, and I receive that on my receive pair. There's a power device. AP1, I'm a Cisco AP, so I exchange CDP messages, and I tell him what my power requirements are. It's as simple as that. Cisco, or some certain Cisco devices, also support a Cisco proprietary PoE implementation. So like with everything else, Cisco have got their own implementation or way of doing things for power over Ethernet. So this is Cisco Universal Power over Ethernet. This allows us to provide more power out each port. So Cisco UPoE supports 60 watts of power per port. The new UPoE Plus supports 90 watts of power per port. And like I said, the idea, or I think the end goal, in my personal opinion, is to have every device receive their power over Ethernet. And so that means it just makes it easier. There's a cost benefit as well, because we don't have to spend money on getting additional power installed in the area. We can just pay for our Cisco devices, pay to get our data points put in place, and then the power and the network access are supplied over a single link. Now let's talk about configuring power over Ethernet. It's relatively simple. We can configure on a per interface basis with the power inline command. We can configure on a global basis by changing the power consumption. I'll talk about that in a second. And we can check PoE information by using the show power inline command. So now I'm going to pause the video. The next time you see my screen, I will be on the console line of a Cisco switch. Hello guys, so welcome back. I'm on the console line of switch 2. I've already got an AP plugged into this switch on fast Ethernet 0/3. So if I do a show power inline command, as you can see, it tells me how much power I'm supplying out this interface also shows me whether power over Ethernet is actually operational. So as you can see, power over Ethernet is not operational on these ports because there's nothing on these ports that need power, but it's operational on FA0 on FA0/3. Shows me how much power I'm supplying, the class, and the maximum amount of power. See here, available, used, and remaining. So available power, this means this is the max amount of power I have available to me assigned to power over Ethernet. Used is how much power we're currently using out of that pool, and obviously remaining is how much power we have remaining. So as an example, let's say that I have 3 devices plugged into here. Okay, and those 3 devices, I'm using up all of the available power. If a device plugs into my interface and needs power over Ethernet, well, guess what? You're all out of luck, buddy, because I don't have any power left in the power pool, so I can't supply you with any power. Think of it as like a power bank, or like a bank where we only have limited funds in that bank, and essentially the funds are assigned on a first come first serve basis. I only have limited funds, so the first person comes, I give him some money, another person comes, I give him some money, and then eventually you'll get to a point where there's no more funds in the bank. And so if somebody else comes, then he's out of luck because there are no more funds in the bank. That's exactly how power over Ethernet works. We only have a limited amount of power that we can supply at each switch port or overall. So if a device requests power and there's no more power left in the pool, unfortunately, buddy, we can't supply you with any power. And if you look over here, it says max here as well. So max means this is the maximum amount of power I can supply out of a single port. So if I have a device, let's say on FA0/1, which needs 30 watts of power, again, he's out of luck because this switch only supports power over Ethernet. It doesn't support PoE+. I can only provide you with 15.4 watts of power. So that means that I can't provide you with the 30 watts that you request, which means that we have to install an additional power supply at that location to power up that device. Now, getting onto the configuration, it's configured on a per interface basis. So if I go into FA0/3, we have the commands here, power inline, and I'll walk you through the commands. Power inline, let's go question mark. As you can see, we've got auto, consumption, never, and static. So obviously, never means even if a device requests power, I will never supply him with power over Ethernet. The power over Ethernet will never be enabled on this interface. Auto means that me and the switch will discuss, and depending on what he wants is how much power I will supply. So we're not statically defining how much power is going to be assigned at this port. All we're saying to this device is that, or all we're saying now is that I will discuss with the device on the other end to see how much power he actually needs. Now, out of some of the other commands that we have here, so auto just means that if a device which connects to this link doesn't support power over Ethernet, I won't supply or send any power over this link. If it does, I will. Now, static, that means that no matter whether the device requests power or doesn't request power, I will supply a certain amount of wattage out this link. Now, obviously, this can be dangerous because what we don't want to do is configure this on a link which goes to a computer, because the computer is going to have its own power supply, meaning we're going to be supplying with too much power. The power inline consumption, that tells us or allows us to essentially predefine that if there is a power device, I want to assign this much power to that device. So let's see these in action. So if I do power, let me say interface FA0/1. If I do power inline, let's go static. Let me say max 7,000. So if I do show power inline, this command basically says that when this interface comes up, I will continuously supply 7 watts of power over the Ethernet link. Even if it doesn't request it, I'm still going to supply it. Auto allows the switch to essentially find out whether there's a powered device. If there is, then I will supply. If there isn't, then I won't supply. Let's have a look at the other ones as well. So I go interface FA0/3, power inline, let's go consumption. And if I do, let's say 5,000 watts, what this command is saying, if I do show power inline here, this command is basically saying that if there is a powered device over this link, I'm going to only assign him 5 watts of power. That's it. Even if he requests more, I want to assign him more, I will only assign him a 5 watts of power. So power inline consumption allows us to statically define how much power is provided out of a port. If that port or if the device needs power over Ethernet. Static is different, so it's important to realize the difference between consumption and static. Static, we're always supplying power even if the device doesn't need it. Consumption, if the device needs power, this is how much power we're going to be providing that device. And obviously auto, we first work out whether that device needs power and then automatically work out how much power that device needs. So I go interface FA003, power inline auto. That's fine. If I do power inline never, this just turns up power over Ethernet. So if I go to show power inline now, this command basically just says that even if power over Ethernet is needed over this interface, I will not supply any power. So even if there's a power device, he's not getting any power. He's all out of luck. So as you can see, what would you do in a real life environment? Just leave it as auto, because essentially you want your switch to negotiate and find out whether there's a power device over the link, and then you want him to negotiate with the power device to see how much power he actually needs. I can't really think of any cases where we would statically define power to always be sent out of a port. Maybe if you know that there's always going to be an AP or an IP camera out that port all the time. The other configuration being consumption. Maybe we only want to provide a certain amount of power. So let's say that we have a IP camera which only needs 7 watts of power. Then we could configure power inline consumption for that. That means that if somebody plugs in a device which they shouldn't, let's see an AP, the AP wouldn't receive enough power to actually power up. Guys, power over Ethernet is really that easy. So that's simple, literally just providing power to a device over an Ethernet cable, allowing the network access and power, and it's used for devices which don't require that much power, because obviously there's a limit on how much power we can provide out each switch port. And on top of that, it depends on what standard with a PoE, PoE Plus or PoE++ that the switch is using. So if you found this video useful and you have enjoyed this content, then please subscribe to my channel. And thank you very much for viewing.